Welcome to today's video. It's finally time to get Suzuki's up and running, and this is something that I've been wanting to do for a really long time, but it was really hard to track down a Suzuki here in Ireland that I could use for all of this. So today we're going to go through the process of 3D scanning the rear master cylinder and swing arm, making up the magnet holders and sensor holders, printing them out on the 3D printers, and getting everything fitted on this bike so that we can offer it to our customers all around the world. So come on, join me for today's video of getting Suzuki up and running on MotoClick. So this is the area here where we fit our sensor. So what I'll have to do is I'll remove the rear master cylinder here and I'll remove this magnet holder. I'm even calling it a magnet holder. This is a brake line clamp. But what I do is I replace this part here with the part that holds our magnet. So that way when the swing arm moves up and down, the sensor is able to pick it up on the master cylinder here. Okay, I have everything set up for scanning now. So what I want to do is scan that area on the master cylinder where the light is flashing on it. And then that takes a 3D copy here and puts it into my laptop so that I can model it up in SolidWorks. And after that, what I'll do is I'll scan up the swing arm area there as a second file. And that way then I'll have the two surfaces that I need for the magnet holder and the sensor holder to work properly. So now you can see it's scanned up here. So it's had some of the pre-processing done to try and tidy up the gaps and stuff like that. But this should be usable now once I import it into SolidWorks. Right, I have my second scan done now of the swing arm area, so I'll just tidy this up to get rid of all the excess. And now with the excess gone, I just have the surface that I'm really interested in, which is trying to get the magnet holder to fit on this here where the brake line clamp is. Okay, I open up the master cylinder now in a software called Mesh Lab, and if you look down here, you'll see it's got 139,000 faces. So the trouble is when I try to open this in SolidWorks, the SolidWorks crashes because it's not able to deal with so many faces. So what I have to do is I have to go in here and reduce the number of faces. And to do that, I go into filters, remeshing simplification, and then simplification quadratic edge collapse decimation. And here it gives me a target number of faces, and I set this to 5,000. Then I press apply and let it work away here. And now you can see it's reduced. So the part now, it looks more kind of triangle-y, if you see all that kind of triangle-iness, and the number of faces has been reduced to 5,000. But now that will allow me to open it in SolidWorks. And this is it in SolidWorks now. So basically what I have here is a platform that I can build off. So I'll hide this surface here. And once that's gone, now you can see the part that I have left. So this will allow me to give me something to get a start on aligning the sensor and making sure we have enough space to work with. These are all the attempts at making parts now, so you can see I've gone through 3 different designs of the front magnet holder, and then this is remnants of the rear magnet holder as well, where I was trying to get the position correct. This I was printing out in our final material here, but I didn't have enough support on this end and it ended up messing up the print pretty bad. But you can see here the design steps I'm going through to try and get everything located right. So a lot of it was to do with this position of the magnet here to bring it closer to the sensor wand, and the same on the rear then as well to bring this further forward. So I'll show you now what it looks like on the bike with the final parts. This is the rear sensor. You can see on the back side of it here how it's taken up the shape of the master cylinder that we 3D scanned. And I have this set in Raytech Magic Gel as well, so I can pull the sensor back out if needs be. So there's 2 channels here for cable ties to go through, and the cable ties wrap around the master cylinder then through this hole. Looking in from the other side here now, you can see how the rear sensor has been fitted, and then you can see the rear magnet holder there as well. And the cable then, I like to bring it up and bring it away from the exhaust. So you can see the cable there in the center of the view, just where my finger is, and then I bring it up inside the engine mount here. The cable comes up along in behind and then up along through the throttle tubes, throttle cable, and into the MotoClick CCU then. So the CCU is located here behind the front number plate. We have the front sensor one plugged into it as well. And then we have our handlebar controller up here as well, which has a satellite antenna in it and the button to start and stop recording the data. So something that's going to be a little bit tricky on this Suzuki is the OBD connector. You can see it located in here. So this OBD connector has a jumper wire on it here for setting the trim of the fuel. So rather than doing it over an app or whatever, there's a little cable in there. It's quite hard to see. You can see that cable now, so that's a jumper cable to set the fuel to be lean or rich.
So we'll have to accommodate that in our power supply cable as well, because the front two pinouts here are the positive and negative that we need to power the motor click system. So you'll plug in the OBD cable into this and that'll feed power up to the CCU. And then in order to change the mapping, what you'll have to do is remove the terminal here and swap it into one of the other locations. That would be the advice given with the system. But that's it. We have our Suzuki pretty much up and going here now. So I'll show you the front magnet holder as well. So you can see here the front magnet holder design, quite a bit different from the prototype ones that I was showing you. Not really happy with the quality of the print here. That must be something to do with the settings that I was using. So we'll clean that up then for the production versions. But really happy with how it fits. It's really quite strong and sturdy. And you can see there how the brake line isn't moving up and down or anything. This is just a KYB AOS fork tube. So we already had that sensor ready to go. And we have the fork collar that fits on here. But I didn't want to take off the whole fork leg and everything just to fit that fork collar. I know it works. I'm just trying to save myself a little bit of time. But that's it now. The Suzuki is all ready to go here with motor click system on it. So I have a plan that I want to do with this tomorrow morning and then get it back to its owner. So really big thanks to the owner for lending me this bike so we could get it up and running. That's it for this video then. I hope you enjoyed it. We did miss a step there of calibrating the rear, but there's enough videos of that on YouTube for you to watch anyway. So now it's just time to get this bike back to the good owner, Tom. I'm very, very thankful to him that he gave me a lend of this bike so we could get this work done. And I'm going to leave you with a little edit that I put up on Instagram and TikTok about how beautiful I thought that this Suzuki was. See you in the next one. Some bikes in this world are just too beautiful not to share. With the fog rising over the river, I got the bike set up and I wanted to see what I could do with this wonderful summer's morning. Here's the result.